Good morning, and here it's evening, as you can see behind me. Thank you to GNSS Asia for giving me the opportunity to present in this event. This presentation on behalf of the Philippine Space Agency is entitled Bridge, Uplift, and Empower Through Space Using EU Space Data for Maritime Applications in the Philippines. The monitoring, mapping, and understanding of a variety of environmental issues related to natural hazards, marine environment monitoring, maritime navigation, and vessel detection are important concerns in the Philippines and in our region. In this brief presentation, I hope to give a window into the usefulness and benefits of Copernicus space missions in addressing these incessant challenges in the context of the Philippines. So first, an introduction. The Philippines Republic Act 11363 was signed on August 8, 2019. It's an act establishing the Philippine Space Development and Utilization Policy and creating the Philippine Space Agency and for other purposes, also known as the Philippine Space Act, mandated the Philippine Space Agency, or PhilSA, to be the primary policy, planning, coordinating, implementing, and administrative entity of the executive branch of the Philippine government for the National Space Program, in line with the Philippine Space Policy. The establishment of the PhilSA addresses 6 key development areas, as you see on the right: national security and development, hazard management and climate studies, space industry capacity building, space research and development, space education and awareness, and international cooperation. Understanding the space value chain, in this case for downstream Earth and marine observation, is important in being able to fulfill our KDAs. A 2019 Australian government report on the current economic value of Earth and marine observation, or EMO, to APEC economies described the value chain as shown on the left. The first component in the value chain is access to the Earth and marine observing, or EMO infrastructure. This EMO infra will enable us to have access to data where data must be available in suitable form. Next, the technical capacity to download and host the data must be available or should exist. Once data is hosted and available, there must be analytical capacity to interrogate the data. And then this leads to actionable insights, which must be matched with the impetus and funding to act on said data. Often, this can be the valley of death. Now, once action is taken, this can lead to the realization of economic value and benefit. Now, as a country, we aspire to establish capability and create value at each of these steps in the value chain. PhilSA aims to establish the economic contribution of EMO by pushing its application to industry, disaster risk reduction and management, and a broader society to be used to inform better decisions and by public entities, private businesses, and members of the community. In the next slide, we show examples of these efforts. First of all, the Philippines has invested in space, science, and technology, representing the EMO infrastructure and technical capacity in the value chain. For the last 6 or so years, 4 small satellites, with the efforts of Filipino engineers in partnership with Japanese universities, have been put into orbit, namely Diwata 1, Diwata 2, and the microsatellites, and the nanosatellites Maya 1 and Maya 2. The satellite development efforts are complemented by ground infrastructure facilities spread across the country, which are used to communicate with Philippine Earth observation satellites and those of other countries that we have access to. There's also a facility for high-performance scientific computing located in Metro Manila, which is connected to the National Research and Education Network, or NREN, the Philippine Research Education Government Information Network, or PREGINET. PREGINET, on the other hand, is connected to regional RENs, such as the Asia-Pacific Advanced Network and the Trans-Eurasia Information Network, or TAIN. These space and ground infrastructure equip the Philippines with a capacity to create and add value from space through the creation of competitive upstream industries and the generation, processing, analysis, and distribution of vital geospatial information. Now, also under EMO infrastructure component, the Philippines has been utilizing high-resolution imagery to regional global resolution satellites for various environmental applications. The Philippines only has 2 Diwata Earth observing satellites, and applications from these satellites are rather limited. To augment the need for available data for other applications, we subscribe to other free and commercially available data sets. Complementing DWAT at moderate resolution, the Philippines subscribed to Dove and Novasar satellites for applications where high resolution images are needed. We avail of the data from GOI, ComSat, Digital Globe, and Cosmos SkyMed. We're also taking advantage of the free and open data from US satellites, namely Landsat, Terra, and Aqua. And of course, the European Copernicus Sentinel satellite series with optical and SAR imagery capabilities. The next component of the value chain is ensuring that data are available in suitable form. In this regard, the country's investments in space infrastructure enables us to receive information from orbiting satellites. We mobilize this information to provide space-enabled services that will help inform policies and decision support systems to improve the lives of our countrymen, especially in areas of national security, disaster risk reduction, management, coastal and ocean and agricultural sectors. Enabling data-driven or evidence-based policies for promoting digital inclusion, better governance, and knowledge economy is one way that we can create value from space. The stack on the bottom left shows different government agencies in the Philippines and public institutions and academia and how much data they have accessed over the past several years from our archives of satellite imagery from those sources that you saw earlier. Use cases in maritime and marine environment in the Philippines using Copernicus satellite data are described in the succeeding slides. Mobilizing space information through automated workflows, as shown here, represents the analytical capacity to interrogate data in that value chain. Data from satellites are downloaded and accessed to our ground receiving stations. Analysis-ready data, or ARD, are generated by pre-processing ingested information from the ground receiving stations and data portals. Corrections to the data through calibration and validation are applied during pre-processing and post-processing. After post-processing, value-added products are generated. This feeds to various stakeholders and users of the data. Among the applications in monitoring maritime activities or ship detection, monitoring air and water quality at seaports, and classification mapping of Ventic habitats. Let's start with ship detection. As you can see, the Philippines is an archipelago where shipping routes for domestic transport and trade dominate our surrounding seas. The domestic routes are traversed by tanker vessels used for the distribution of petroleum in the country, merchant fleets used for domestic trade, and vessels conducting fishing operations. Using Sentinel-1, mapping of the vessels surrounding the country was visualized using artificial intelligence or AI techniques. Ships generally exhibit a stronger backscatter value compared to the background. The AI algorithm detects those occurrences and tags them as ships. The number beside those red dots show the confidence level of the algorithm in identifying the object as a ship. Approximately for this purpose, 3,000 ships so far constitute the training data, but this set is growing by the day. The image on the left shows the detected ships, the red dots within the Philippine territory with Sentinel-1 coverage. The image on the right shows detected ships between Negros Island and the Zamboanga Peninsula, shown on the yellow rectangle on the left image. In this slide, using Sentinel-1, two ships in close proximity may indicate suspicious, possibly illegal activities such as smuggling. The two ships detected in the southern part of Palawan province in the southwest of the Philippines are less than 300 meters apart. Extending the study might indicate common transshipment points at the sea where authorities can and should monitor more closely. The image on the right shows possible intrusion of a vessel within a protected marine area, the Tubbataha Reef, obtained using Sentinel-1 data. The Tubbataha Reef National Park is a marine protected area and world-renowned diving site. It is home to more than 1,200 marine species, including seagrasses and algae, corals, sharks, rays, fishes, sea turtles, seabirds, and marine mammals. Ship monitoring complements the efforts of various maritime authorities in monitoring these protected areas. In these juxtaposed images, Sentinel-1 data was used in visualizing the presence of ships in Manila Bay from January 2019 to September 2020. This period covers the onset of the COVID-19 pandemic and the height of the lockdown measures in the Philippines, particularly in the metropolitan Manila area. Manila Bay, as seen here, is the country's biggest shipping port, which also serves as a ferry terminal, a fish port, and yachting marina. Its orientation towards the open sea allows the country to benefit from a transboundary development and trade with the rest of Asia and the world. This graph shows the noticeable trend of increase in the number of ships detected within the bay at the onset of the quarantine or lockdown period in April 2020, March to April 2020 in the Philippines, which was more or less sustained throughout the shift in quarantine or lockdown levels over the next few months. This slide shows NO2 mapping in Manila Bay ports from Sentinel-5P datasets. Nitrogen dioxide is part of the air pollutants usually coming from road traffic and fossil fuel combustion. Related to the presence of marine vessels shown from the previous slide, Manila Bay's NO2 pollution from 2018 to 2021 was mapped along the ports in the Bay area using Sentinel-5P as seen on the image. The ports indicated by the white circles are labeled 1, 2, 3, 4, 5. Now, among the ports, the Port of Manila has the highest NO2 level, shown here. This is the graph of NO2 levels in Manila Bay. During this time, a drop in NO2 in the area is observed in the implementation of the community quarantine or lockdown during the COVID-19 pandemic in the country from the middle of March to April of 2020, last year. This rises again in the next few months. Now, this can be explained by the reduction of road vehicles, which adds to the NO2 average that is measured from the map. However, this observed decrease in NO2 levels in April contradicts the increase in the number of detected ships that were docked in Manila Bay, which was shown in the previous slide. This suggests that the ships seen in the area were either docked or stranded and not really generating significant emissions that would affect the air quality measurements. This slide shows the application of Sentinel-2 and Sentinel-3 on water quality assessment. In March 25 of last year, 2020, pictures of Manila Bay waters turning turquoise circulated in the newspapers a week after Metro Manila and the entire Luzon Island was locked down due to the pandemic. Using Sentinel-2 and Sentinel-3, an estimate of the chlorophyll A concentration and water turbidity. This is chlorophyll A and this is turbidity. In the area from March 13 to 28 last year was measured. High water turbidity could indicate high water pollution, while chlorophyll A concentration suggests algal abundance. Now, in the images, relatively high chlorophyll A and turbidity values were observed, suggesting that the change in color of Manila Bay waters could be attributed to high water pollution. More turbid water is identified in March 25. However, since the chlorophyll A levels did not increase significantly around the bay, this area in the dashed rectangle, the change of water color is perhaps not due to algal bloom. Further study is therefore needed to determine the pollutants in the bay. And this slide demonstrates that Sentinel-2 multispectral images may be used to map different benthic habitats in coastal areas. Benthic habitats refer to those associated with or occurring on the bottom of a body of water. Support vector machines or SDMs were implemented in this benthic habitat classification, inventory and monitoring the extent of coral, seagrasses, and mangroves are essential for protection and conservation of the healthy coastal ecosystems, which of course are abundant in the Philippines. And lastly, with the country's investments both in space infrastructure as well as technical and analytical capacity to process and generate information, we undertake efforts aimed at cascading the importance of the space value chain components and its benefits to decision makers and those who can and should act on the information. By doing this, we can create value. The pictures here show initiatives to conduct trainings to government offices and agencies that translate the capability to groups with a proper mandate in a certain domain. For example, the Philippine Statistics Authority for conducting the census, the Department of Agriculture for food security, the Sugar Regulatory Administration for mapping and monitoring sugarcane crops. In addition, disaster risk reduction management and response we interface with the Office of Civil Defense, the various local government units and volunteer organizations, as shown in the picture on the right, where maps generated by the technical teams are used by emergency personnel in responding to a landslide event that occurred in Cebu, Philippines. So we're attempting to save lives and property. So let me end my presentation by sharing the vision and mission of our Philippine Space Agency. The PhilSA envisions a Filipino nation bridged, uplifted, and empowered through the peaceful uses of outer space. And our mission is to promote and sustain a robust Philippine space ecosystem that adds and creates value in space, for and from Filipinos and for the world. Thank you very much for your kind attention.